Welcome to the Day 4 5.8 video. Today we are going to learn about graphing quadratic inequalities. This is going to be very similar to before when we graphed quadratics in standard form, but now instead of equations we're going to have inequalities. This video is no calculator. So let's just jump right in and start with the first example. So we have to identify all the same information that we did before, the vertex, the axis of symmetry, the y-intercept, etc. So if we remember from before, the vertex in standard form is negative b over 2a. That gives us x, and then to find y, we substitute x back in. Remember that the number in front of the x squared is a, number in front of x is b, and then the number without an x is c. So our x in this case is negative b, negative 2, over 2a, 2 multiplied by 1. So negative 2 divided by 2 is negative 1. So our vertex is going to be negative 1 comma some number. In order to find what y is, we need to substitute x back in. So I have negative 1 squared, add 2 multiplied by negative 1, add 1. So this becomes 1, subtract 2, add 1, which is just 0. So my vertex is negative 1 comma 0. I'm going to make sure to write that in the middle of my table. Axis of symmetry, remember, just goes along with the vertex. It's the x-coordinate of the vertex. So the axis of symmetry is going to be x equals negative 1. Remember that this needs to be an equation. So negative 1 is wrong. It has to say x equals negative 1, because this is going to be a vertical line. To find the y-intercept, this is when x is 0. So all I have to do is substitute in 0. So I get 0, add 1. So the y-intercept is 0, 1. And the domain and range we're going to leave until the end. So now let's move on to doing the table. So going down from negative 1, I get negative 2 and negative 3. Going up, I get 0 and 1. Okay, well I already know the point 0, 1 from the y-intercept. By the symmetry of a parabola, that means negative 2, 1 is going to be a point. So all I really need to find now is what happens when I substitute in negative 3 or when I substitute in 1. I'm going to substitute in 1 first because that's easier. So I have 1 squared, add 2 multiplied by 1, add 1. So this is 1, add 2, add 1, which is 4. So 1 comma 4 is a point. Just to make sure that I'm right, I'm going to substitute in negative 3 also. Because of the symmetry of a parabola, I should also get positive 4, but let's see. So I have negative 3 squared, add 2 multiplied by negative 3, add 1. Negative 3 squared is 9, so I have 9 subtract 6, add 1, which again gives me 4. And now I'm ready to graph. I'm going to start by graphing the axis of symmetry, the x equals negative 1. Remember that that's a vertical line going through negative 1. Okay, now I'm going to start plotting my points. My vertex is negative 1, 0. And then I have 0, 1, and negative 2, 1. And I have 1, 4, and negative 3, 4. Okay, so it looks like my parabola is going to be opening up. I just need to do a little mental check. Does that make sense? Well, the number in front of the x squared, the a value is 1. Positive number, so the parabola should be opening up. Okay, now this is a review of everything that we've done before. The part that's changing now is that we have an inequality. It's not an equal sign, it's a greater than sign. So rather than having a solid parabola, it's going to be dotted. Sorry, that should have been dotted. Remember that it's only equal to if there's an equal sign, so greater than or equal to, less than or equal to. And the last thing now I need to do is I need to figure out where to shade. When we did inequalities before, we always substituted in a test point. So we're going to substitute in a test point again. The easiest test point, in my opinion, to substitute in is 0, 0. So I'm going to erase this stuff at the bottom, and I'm going to substitute in 0, 0. Okay, so I end up with 0 is greater than 0 squared, add 2 multiplied by 0, add 1. So 0 is greater than 1. Is this true? No. So I don't want to shade near 0, 0. 0, 0 is on the outside of the parabola. That means I want to shade on the inside of the parabola. So I want to shade all of this stuff. Now we are not going to do domain and range for inequalities, so you can just cross those two right out. Okay, so that was the first example. It's almost exactly the same as what we did before. We just have to figure out the shading. That's the only difference. So we have a few more examples. Just to solidify this, I'm going to do the second example with you. The first thing that I'm going to ask you to do is change one of the numbers in this equation or in this inequality. Instead of a 3, change that to a 4. If we use 3, we're going to end up with a whole bunch of decimals, and I don't want us to end up with decimals. Okay, so finding the vertex is the negative b over 2a. In this case, b is 4, so it's going to be negative 4 over 2 multiplied by negative 2. So this is negative 4 over negative 4, which is positive 1. And now to find the y, I need to substitute in positive 1. So I get y equals negative 2 multiplied by 1 squared plus 4 multiplied by 1, add 5. Remember that we changed that 3 to a 4. Okay, 1 squared is 1, multiplied by negative 2 is negative 2, add 4, add 5. So negative 2 add 4 is 2, add 5 is 7. So my vertex is going to be 1, 7. Axis of symmetry, remember, just goes along with the vertex. So my axis of symmetry is going to be x equals 1. Remember that it's an equation. X, just writing negative 1 is incorrect. You have to actually say x equals 1. Okay, y-intercept comes from when I put in a 0 for x. When I put in a 0 for x, the first and second terms just are 0. So all I'm left with is 5. So 0, 5 is my y-intercept. Remember that we're going to skip domain and range for inequalities. So now I'm ready to fill out my table. Two numbers below 1 are 0 and negative 1. And then I get positive 2 and positive 3. When I substitute in 0, I get 5. By the symmetry of a parabola, I know that if I substitute in 2, I'm also going to get 5. That's because 0 to 1 is 1 and 1 to 2 is also 1. They're the same distance from the vertex. So the last two I have to substitute in are negative 1 and 3. So I'm going to do that. I have negative 2 multiplied by negative 1 squared, add 4 multiplied by negative 1, add 5. Negative 1 squared is 1, so this is really negative 2, subtract 4, add 5. So negative 6, add 5 is going to be negative 1. Now substituting in 3, I have negative 2 multiplied by 3 squared, add 4 multiplied by 3, add 5. So 3 squared is 9, multiplied by negative 2 is negative 18, add 12, add 5. So this is negative 18, add 17, which is negative 1. And that's good. By the symmetry of a parabola, those two should match. So now I'm ready to graph. I'm going to start by graphing my axis of symmetry, my x equals 1. Remember that that's a vertical line going through x equals 1. And now I need to start plotting my points. So my vertex is 1, 7. I'm going to start with that one. I then have 0, 5, and 2, 5. I have negative 1, negative 1, and 3, negative 1. Okay, this time it's less than or equal to. Because we have the equal sign, we can draw this in as a solid parabola. And last thing I need to do is I need to figure out my shading. So I can choose any point for the substitution or for the test point, but I'm going to choose 0, 0. So I have 0 is less than or equal to 0, add 5. So 0 is less than or equal to 5. Is that true? Yes, 0 is less than or equal to 5, so I want to shade where 0, 0 is. In this case, 0, 0 is on the inside of the parabola, so I'm going to shade everything inside the parabola. Okay, so we have two more examples to do if you would flip the page. Right now, I would like you to pause the video and try this example 3 on your own, please. Do everything. If you don't remember, go back to the previous two examples. After you are finished and you have a graph, come back and we will go over it together, please. Okay, so our vertex is negative b over 2a, so negative 2 over positive 2, so I have x equals negative 1. When I substitute in negative 1, I get negative 9. My axis of symmetry then is x equals negative 1, because it goes along with the vertex. My y-intercept should have been 0, negative 8. Domain and range we're skipping. I know I'm going quickly, but we should know how to do this by now. It's okay if you made a little mistake, but we should know how to do this. In my table, I'm going to start with the vertex, so negative 1, negative 9. Go down 2, so negative 2, negative 3. Go up 2, 0, 1. I already substituted in 0 because it's the y-intercept, so 0, negative 8. By the symmetric properties of parabola, when I substitute in negative 2, I should also get negative 8. So now I just need to substitute in negative 3 and positive 1. Substituting in negative 3, I get negative 3 squared, subtract 6, subtract 8. So this is 9, subtract 14, which is negative 5. Substituting in 1, I have 1 squared, add 2, subtract 8. So this is 3, subtract 8, which is negative 5. Again, by the symmetry of a parabola, these two should match, and they do. So that tells me that I'm on the right track. Now for the graphing. I'm going to start by graphing the axis of symmetry, the x equals negative 1. Okay, and now for plotting my points. My vertex is negative 1, negative 9. I then have 0, negative 8, and negative 2, negative 8. I have 1, negative 5, and negative 3, negative 5. Okay, I have a greater than sign. There's no equal, so this is going to be a dotted parabola. Last thing, I need to figure out where my shading is. Before I do that, I just want to make sure, does my answer make sense? I have a positive a value, it's a 1x squared, and the parabola opens up. So that should tell me that I did something right. Now I need my test point. I'm going to use 0, 0 again. I have 0, add 0, subtract 8 is greater than 0. So negative 8 is greater than 0. Is this true? You should have said no. So I don't want to shade where 0, 0 is. 0, 0 is on the inside of the parabola. That means I want to shade on the outside of the parabola. So hopefully we got that one right. If not, hopefully we now see what we did wrong. We have one more example to do. This one I'm going to leave for you to do on your own. When you come to class tomorrow, we will be checking that you have this one completed. One thing I want to point out, you have a negative x squared, so your parabola should be opening down. So after you graph, do a mental check and say, is my parabola opening down? If it's not, then you did something wrong. Again, we're going to check when you come to class tomorrow. If you have any questions, please bring them to class. Good luck.